Okay, we are beginning sequences and series. Some of this is carrying on from when you were in 9th grade, Algebra 1. Okay, or 8th grade, whenever you took your Algebra 1. But let's look. I want you to take a second and see if you can finish the pattern on the brick wall here. I'm going to give you a minute, and you look and see if you can find that pattern. All right, if you look at this, what's the pattern? What are you doing to get the next number? Where did the 4 come from? Yeah, we added 1 plus 3. So here we're going to add 3 and 3 and get 6. Yeah, you did. Right? I want you to see this because it's really easy, of course. Right? Now this is Pascal's triangle, and it does a lot of stuff for us. It's really cool. So I want you to look at that and tell me what you notice about it. What do you notice about it? This is the answer to a lot of multiplication problems. You're not going to want to recreate this wall every time you do a math problem, but if you understand the wall, you won't need the wall. What do you notice about this? It's symmetrical. So now let's think about this. If I know the left half, do I know the right half? Yes. Now, what do you notice about the very first and the very last number? They're ones all the way down. So how hard is this to know? I don't need to know the ones because it's always ones. So if I just knew 4, 6, I know that's a 4. If I knew this was 10, 10, or 5 and 10, I know that's a 10 and 5. So look at that for a minute, and I want you to really think about what it looks like. It's symmetrical, and the edges are always 1. If you're going into statistics, we use this principle. We need this for our counting principles so we can do stuff really fast. Okay, so I'm going to let you think about this right now. I'm going to come back to it in a second, and I'm going to give you a second to do this how you know how to do it. How do you multiply a binomial? We're going to do these the old-fashioned way. We're going to work hard for a minute. Then you're going to say, oh. So what does this mean? What are you supposed to do with that? Yeah, you do x plus y times x plus y, right? And you get x squared plus 2xy plus y squared, right? Now, what happens if I ask you to do a cube? What do? Well, that means x plus y times x plus y times x plus y. It does not mean x cubed plus y cubed, right? Now, haven't you already done this part? Isn't that answer? Right? Okay, so we've already got that answer. So I'm going to say it's x plus y times x squared plus 2xy plus y squared, right? You have to do 2 at a time when you multiply. So how do I do this one now? I just have to go through and distribute, right? X needs to go to everyone, y does. So let's x times x squared, x cubed, x times 2xy, 2x squared y, x times y squared. Now, I don't know, don't go on. I think I can make this a little easier for you. What do you do now, usually? Do you now start with the y and you do everyone and you keep writing them? It's a little easier if you write underneath. So you can line your guys up and they're easier to add. What's x squared or y times x squared right there? See how they can line up? You can do this anytime and then you don't have to go circle your like terms because they'll all be together. And then y times 2xy is what? 2xy squared, and then y cubed. Now you could just go like this and you don't have to find your like terms. They're like. So what is our answer to this creature? X cubed plus 3x squared y plus 3xy squared plus y squared. Now is the time to think. What? Oh, y cubed. Sorry. Y cubed. Now is the time to think. I want you to look at this guy, and I want you to look at this guy, and I want you to go back up to the pyramid, to Pascal's triangle, and tell me what you notice. What do you notice? I want you to look at the numbers. What? You mean they're all in order and you didn't have to do all this work? Oh, nice. Yes. So you notice when it's 1, 2, 1, that is something squared. 1 and 1 would be something raised to the first power. 1 is what? Anything raised to the 0 power. So if I were to cube something, or I were to 4th, 5th, 6th, 7th, you no longer have to do all this multiplication. You just put the numbers in. But you got to know what's happening with your letters. What's happening with the letters? Tell me what the order is. What do your variables do? Look at that and tell me. Tell me the pattern for the variables. Look at it. What's going on? It's counting down. X counts down. Or the first thing, I'm going to call it X. It's the first, it could be an A, whatever letter. Look at it. 3, 2, 1, and none. Yes. The X's, or the first term counts down. The second term counts up. Hold on. So I want you now to try the 4th. I'm going to pause this for a second so everybody gets time. Now I want you to use your knowledge and see if you can do this. Okay, I want you to think about one other thing. This is cubed. How many terms do you have? How many terms are there? 4. This is squared. How many terms? So this is to the 4th. How many terms? Okay. This is me, the student, just learning. This is how I do it. Now I gave you a plus so that they're all plus signs. And what are the numbers going to be if it's raised to the 4th power? 1, 4, 6, 4, 1. Of course, you don't have to write the ones, right? That's understood. But I'm trying to get your eyes to really say, oh, that's right here. And what's going to happen with the letters? Yeah, what is this one? X to the what? Look. 4, 3, 2, 1, and none. And then what do your Y's do? 4, 3, 2, 1, and none. How easy was that? What's your other option on this problem? If you don't pay attention to this, what do you have to do? You have to do this. You got to FOIL and distribute 3 times. Who wants to do that? I'd rather know this. Isn't that cool? Admit it, this is really cool. This is like magic. Like, why didn't you tell me this 3 years ago? You weren't ready. Okay, now we got to go look at something else because we're going to tie it together with our wall. This is a formula that you're not going to use anymore because your calculator now knows how to do it. Okay, but I want to show you where it came from so you know how to count it. This is NCR, it's a binomial coefficient, and that's going to tell you all of these numbers. You can pull them out of your calculator. Okay, so what I want to show you here is how to key them in. Okay, so how do we key those in? There's a couple ways. Let's do both of them and you pick the way you want. So get your calculator and you're going to go math, which is that key right there. Then PROB, which is over here. And then do you see the little guy on number 3? You just put the numbers in, 9 and 2. Whoops. Math, PRB, look for the one that looks the same. And make sure your finger doesn't slip off the key. You type them in and you get an answer. You can also do alpha window 8. Depending on which calculator you have and which way you like it. Just make sure that you can type that in. And I want you to notice that this notation is the same as this. This means 11C4. Sometimes it's written that way. It's easier to write. It's shorter. So type that one in and tell me what you get. Put that into your calculator. You can use math probability 3 or alpha window 8. I like alpha window 8. I feel like I can do that faster. And you just type in 11 and 4. Everybody okay with your calculator? Everyone at home, you got your calculator? It's going okay? This is the by hand way to do it. If you're going to put an n factorial and n minus r times r factorial, most of the numbers go away and then you just have to multiply them by hand. We don't really use that anymore because we all have our calculators. So now I want to give you a second and I want you to go type these in because I want you to see what they are. These are important. You're not going to want to type them in because you're going to see a pattern. So go type them in and look them up and tell me what the pattern is. Tell me what you know. You don't want to type them in every time. So let me give you a minute. Okay, y'all, if you've got the other calculator, it types in the same way, but if you've got the one that doesn't have the LED screen yet, when you want to type in a 9C2, you have to type in the letter 9, right? Can you see that? There we go. So you type in the number 9, then you go math over to PRB still with your arrows, and then come down to 3, and then you'll type in the number. So if your calculator doesn't have the LED screen and give you the box, you've got to do the number, the NCR, and then the number. Then you hit enter and you get the same thing. Does that make sense? Okay, so let me. Okay, so what is 8C0? What'd you get? 1. What is 8C8? Okay, so now let's think about that. Are you ever going to type in a 0? If it's 0 or if their numbers are the same, are you going to bother to type those in? No, that's a 1. What did you get when you typed in 81? What'd you get when you typed in 87? Okay, so what pattern are you looking at there? So this is, I'm going to go label some stuff now. We're going to go back to the pyramid and you're going to be like, oh, right? Now this is, when we go back to the pyramid, we said this was to the 7th, right? So guess what this is? 7, 0. Guess what this is? 7 what? What is this? What is this? Right? Isn't that cool? We got to really think about this. It's all patterns. Now, when there's a 7th power, how many terms did we get? 8 terms. 6 of them had 7 terms. Whoops. How do you like my terms with 2 R's? So, why is that? It's because we start counting with 0. That's the thing you have to remember. We start counting with 0. So, if you have 7, 1, it's going to be 7 because it's the second brick in. And notice the second brick in is always that power, isn't it? And since it's symmetrical, if a 7, 1 is a 7, then that's the second one in, then the second to last one, which would be one number less, has to match up. Really look at this pattern. He who sees the pattern is like, whoa, I like this. It's so easy. I'm never going to foil again. Foiling is easy, but when we get big powers. Does everyone see this pattern? And remember, 7, 0 is the same thing as this, right? Writing it either way. I like to write them up and down because they take up less room, right? It's the same notation, same instructions. So now, if I give you something to the 6th power, let's pretend like you don't have your brick wall because you're not going to carry that with you everywhere. You just need a calculator. So let's do this together because I want you to see how easy it is. First of all, if there are 6, if the power is the 6th, how many terms will we have? 7. So I write a square or a line for each one. Right? I have 7. Now, do I know the letters? Let's put the letters in first. The letters are easy. What's the first letter? A what? A to the 6th. Then what do we have? Now I'll start. That's my A. Now I'm going to do my B. How does my B start? That's B to the 1 and then no B's. Does anyone have any question about where those powers came from and how we did that? Counted down, we counted up. Now the question is, how do I do my coefficients? Well, what do we know is true? We know the first one is 1 and the last one is 1. And this is a 6, so what's the first one in? How many do I actually have to look up? No? 2, because these two have to be the same because it's symmetrical. How am I going to find that number? Well, let's think about what it is. This is a 6, 0. This is a 6, 1. This is a 6, 2. This is a 6, 3. So you only have to type those into your calculator. So put in a 6, 3, right? That's a 6, 2. And what's a 6, 2? 15, right? So that's a 15. And if that's a 15, what's this one? 15. And then I got to find a 6, 3. So I can go up and I can copy that. And I can just change the one number and save my typing. All right, admit it. Who thinks this is really cool? fast math. It's cool. Admit it. Now this is a plus, so they're all plus signs. We'll worry about a minus sign in a minute. Now, I want you to think about something. Most of the time, I'm not asking you to write out big, long strings of numbers. Most of the time, I want to know what the fourth term is, or what's the sixth term, or what's the third term. I want to know just one term. So let's number these so we can read what the terms are. This is the first term, right? The second term, the third term, the fourth term, fifth term, sixth term, and the seventh term. So what do you have to be careful of as a student? If I say it's the fourth term, what are your numbers going to be? What is your brain going to want to write down for your number? You're going to want to write down a 4. But the fourth term is really a 3. Why is that? Why does it feel off? Because we start with 0. So that's the thing you're going to have to put in your head is we start with 0. So if you want the third term, it's really a 6-2. You want to know that. You don't want to write out pyramids of numbers. It's a 6-2. Now, I'm going to write all of these out because I want you to pull another pattern for me, right? I want you to tell me if you just wanted the fourth term, how you would know what the numbers on A and B are. Look at the pattern. Look at the pattern and what matches up. What matches up? First person to do it wins. There are no prizes, but you win. Tell me how looking at this, I could figure out those little exponents without having to write the whole string. You're right. Let's look at this one. What's true about this number and this number? Oh, really? So you mean I don't have to do any work? I don't. That's a 1. Look at that pattern. Everything matches up. And then Ben mentioned, how do we get the number here? Well, what do these two numbers always add up to? Why do they add up to 6 in this problem? Because it's to the 6th power. It's like magic, right? So notice here, 3 plus 3 equals 6. 2 plus 4 equals 6. 5 plus 1 equals 6. 4 plus 2 equals 6. 5 plus 1 equals 6. This thing is all patterns. You only have to learn the pattern and then life is extremely easy, right? You got it? Does it make sense? Think for a minute, make some notes to yourself. So if I wanted the 5th term, if I told you something was raised to the 6th power and I wanted the 5th term, you would count 6, 4, because you got to go 1 less. And then you know this 4 goes with that. And these 2 have to add up to 6 so you can figure out the inside number. So do you have any icky work to do? No. All right. Is everybody good with that? You got the pattern. Do you need a minute to think about it? Process. I'm going to pause this again. This is going to be the weirdest recording. All right, we're going to do this with a number. We're just going to do it the same way. Okay, does not change anything. So this is to the 4th power. So how many blanks do I need? 5, because we start counting with 0, right? So there's 0, 1, 2, 3, 4. And what do I do? Again, I'm going to color code mine. So here's x. X to the 4th, x cubed, x squared, x, and no x, right? Now I'm going to do 2. It's just the second thing. It doesn't matter. There's a number. So this is going to be 2 to the what? 2 to the 4th, 2 to the 3rd, 2 squared. And don't finish these. Don't make 2 squared 4. Write this pattern out so you see it. Just 2 to the 1 and then no 2's. Okay? And how do I get my numbers? That's 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. Now you guys already told me what 4, 0, and 4, 4 are. What are they? 1s. And you told me what a 4, 3 is. What's the first number in always on your bricks? A 1 is the second number in, and if they're 1 apart, it's the second number in this way. And what is that number match? It matches your power, right? So if this is to the 4th, that's a 4. See, I don't want to type those in. So how many do I really have to type? 1, just that middle one. So, and look, I could go up and copy that, and I could just change the numbers because I'm a lazy bum. What is it, 4, 2? 6. Now, probably I'll get to where I know the 1, 4, 6, 4, 1. All right. Am I finished this time? I'm not done this time because this is a 2. So I'm going to need more blanks. When there's a number, I have to fix it. All right. So the first one is not going to change, correct? That's not going to change. That's x to the 4th. And again, I gave you all plus signs. Now this one is actually going to be what? Can I multiply 4 and 2? Yes. So this is really what? 8. Now this one is 2 squared, which is 4, and 4 times 6 is what? 24. This is 2 cubed, so that's 4 times 8. So that's what? 32 with my x. And this is 2 to the 4th. That's still not hard, is it? Much better than taking x plus 2 out 4 times and multiplying it. Is that okay? Did you have a question? Okay. So if you have numbers in there, you've got to finish. 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. So if you got a number, you got to fix it. So now, of course, I'm going to give you a minute again, and I'm going to let you try this one and see if you see what happens to the signs. So take a second and try. All right. So we're looking at a minus sign. Are any of the numbers going to change or just the signs? Just the signs, right? So I already know that this is what? Y to the 4th, right? 8y cubed, 24y squared, 32x, y, and 16. Now we got to figure out the pattern with the signs. So instead of being a 2, it's going to be what? This time it's going to be -2. So what's going to go here instead of a plus sign? Minus. But then what's going to happen here? Why is it going to be a plus? Because this is what? Squared. So what's going to happen to your signs on this? They're alternating. Why are they alternating? Yes. Let's write a note to ourselves. Signs are alternating. Why is that again? Because a negative to an odd power is negative, and a negative to an even power equals positive, right? And as we count down, our powers go in order, right? 4, 3, 2, 1. So if we're in front of an odd power, we're going to be negative. If we're in front of an even power, we're going to be positive, right? Does that make sense? You got this? You got it? That's good, because now I'm giving you your test. We're almost done. Are you ready to try this? You are. So again, I'm going to give you a little time. I'm going to go through it all, but I want to give you time to try it first. Okay, I want you to notice something right out of the gate. The Y, the second thing, is going to be fifth, fourth, third, second, one, and none. So right here in this second blank right here, Y is raised to the first power. So what sign is going to go here? 1 is an odd power, and this is negative. So what sign are we going to start with? Negative, right? Because it's going to be a negative Y, and it's raised to the first. So you can get your signs in. Okay, now I'm going to give you time to work. Okay, here we go. What do? Well, we do the first thing. And what do we do to the first thing? If this was just X, what would you write here? So what is this? 2x to the fifth, 2x to the fourth, 2x cubed, 2x squared, 2x 1, and no 2x's, right? It doesn't change. You just write what you see. And now, what are we going to do with this fella? What do we write? Y to the fifth, y to the fourth, y cubed, y squared, and just y, correct? Now we put our numbers in. What numbers go on a 5? Well, we know it's what? A 1 and a 1, and what's the first number in? Your power. And what are the two numbers that go there? They're 10s. Anybody have trouble getting that much done? That's just counting down and putting the numbers off your bricks, right? And if you needed that 10, what would you type in here? It'd be 5 and 1, 2, third term, so that's a 2, right? Okay. Now you just finish it out and do the little bit of arithmetic that's left. What is 2 to the fifth? It's 32, right? You already have your signs done. So right here now, we have 2 to the fourth. What's 2 to the fourth? So that's 16x to the fourth. And what's 16 times 5? Not bad, right? Way better than doing this out 5 times. Now here, what's 2 cubed? 8. What's 8 times 10? 80. And of course, in the end, your variables are going to count down, and they're still, look, 3 and 2 is 5. 4 and 1 is 5. Your variables are going to behave. You just have to adjust your coefficients. 2 squared is 4. 4 times 10. See how the x and y don't change anything? This is 2 to the first, which is just 2. 2 times 5 is 10. That was just 1. Isn't that cool? Now, what's your option if you don't want to get used to the pattern? Then you have to take this and multiply it out 5 times, right? Ooh, that sounds bad. Now, the truth of the matter is, I don't usually ask you to write all those. We're not usually interested in that. We don't usually want the whole string. We want the nth term. I want the 5th term. I only want one term. I want the 5th one. So how am I going to find the 5th one? Well, I'm going to need a coefficient and 2 letters, right? So there's my first letter. What power is it going to be if it's, well, first of all, tell me what my numbers are going to be. If I want the 5th term, this is going to be 12 what? Four, because we start counting with 0. So we're 1 less than we think. Now, tell me what's true. And I'm going to just set up parentheses here. Now tell me what's true about this number. Which one is going to match that? This one, right? These two numbers are the same, correct? Now, you tell me, I need a different color, what this number is going to be and how am I going to figure it out? What does orange and turquoise, what do these have to add up to? They have to add up to 12. So what number goes in orange? 8? Right? And I'm going to write down right? And now I just stick whoever's there inside, right? So an A goes here and a 2B goes there. Now I just finish out what it says. So in your calculator, what is the 12 for? It's going to be a big number. We don't want to do this out. What's a 12 for? 495. Times. A to the 8th is nothing more than A to the 8th, right? It's not a number. We don't fix it. Times. What is 2 to the 4th? So now if you have two numbers, you can go ahead and multiply those in your calculator. Multiply them and see what you get. It's not bad, right? Make yourself some really good notes. Like remember, 1 less than term, because why is that true? Because we start with 0. So the 5th term is 0, 1, 2, 3, 4. Isn't that cool? I just think this is so much fun. Okay. Now it says find the coefficient of the term A4B7. So that means I'm going to always have a number, right? There's 3 little things I need. I need the coefficient and I need this guy and this guy. So what is the 4, 7 telling me? It's telling me that it's a, a 4 and a 7. They're giving me what they want. So if this is a 7, what is this? 7. And 4 and 7 make, that's not that hard, right? And now inside the first thing, I'm going to put the first thing. Inside the second thing, I'm going to put the second thing. And now y'all just have to work with those. So type those in. What's in 11, 7? What's in 11, 7? You got to do, 11C7 in your calculator. 330 times. What is 2 to the 4th? 16. Now, what did I forget to write on my B? Minus, right? Okay. What is -3 raised to the 7th? Negative, right? So now that we have it down to straight multiplication, you just have to multiply any coefficients together. We know it's going to be a to the fourth, b to the seventh, because they told us that. They want us to find this number. So 330 times 16 times negative 2187. See if you got it. Cool. All right.